Hey everybody, how you doing? First of all, that was an exciting introduction. Thanks, Nadia. I don't know where that introduction came from, but it is true. I was also thinking it's an exciting title. I remember when they shared with me what the title was going to be, but they've chosen an even more exciting image. But yeah, we're Tenstorrent. My name is David Bennett, and we're a hardware company. I think we're one of the only AI hardware companies here today. So I think the talk will be at least interesting, and I promise you, it's not about how great we are. We're going to put that a little bit, we're going to sneak that in there. But it actually is kind of my view on why I think a lot of the AI hardware startups out there are in fact in a little bit of trouble. And that's not a negative comment. We're a hardware company, and hardware is a very hard thing to do. And I mean that it takes a lot of money, it takes a lot of time, and there's a lot of challenges. So I think it's important to kind of look at what we think is going on, what I think is going to happen, why the companies are in this space, and what we can do. And I think it's mostly important for nothing more than it's extremely important that we have options in this industry. I was at AMD for about 12 years, and I knew how important it was to have a viable competitor to Intel. And I think in the AI hardware space, NVIDIA is doing a phenomenal job. But there are other kinds of architectures, there's other kinds of compute, and I think it's important that we have a healthy ecosystem of many, many, many AI hardware companies and many, many RISC-V companies out there. And I'll talk a little bit about that today. I won't go through the introduction, but yeah, I've been in the industry, I guess maybe 15 or 16 years. I started in Asia, mostly in Asia, but frankly all around the world with AMD, Lenovo, and I do a couple other side projects. I'm on the board of the Hello Kitty company, which is interesting. If you ever see me on Zoom, I've got a really nice pink Hello Kitty chair. I get a lot of questions about that, but I always make sure that my boss in Japan sees it when I'm on a Zoom with him. Okay, so I want to talk a few things about some major trends that we're seeing in the market. I think that's a good place to start. And there's been a couple of major news stories in the last couple of months, if not last year or two. Number one, NVIDIA. NVIDIA's stock market, don't look in the last couple of days, it's been a little bit of a difference, but NVIDIA's stock market's through the roof, they're firing on all cylinders, they're releasing products. They are by far the leader when it comes to AI and frankly GPU compute. We don't see that changing anytime soon, but let's talk about what that means for the rest of us. AI momentum. I think we've all seen what's going on with ChatGPT. We've all seen all the different services that have popped up. There's companies, there's money, there's hardware, there's software popping up all over the place. But I think for the first time, companies are starting to realize that they can use AI in their business, and more importantly, they can make money. And if they can make money with AI, they're willing to invest more in AI. And that's going to be an important part of what we talk about today. The ARM IPO. This is a big one. For me personally, I was actually quite involved with ARM over the years, both in Japan and outside of Japan. But yeah, their IPO was huge. We all expected it to be. I think more interestingly, some of the news that came out recently, I don't know if you guys saw, but I think it was NVIDIA and AMD announced that they were doing ARM in PCs. Directly against what's going on with x86. I think the NVIDIA news, frankly, is pretty big. They're going to go big with ARM and really try and tackle the PC space with their own CPU. They've done it before, but I think this strikes me as something a little more serious than they've done in the past. And finally, VC. We see a ton of money out there, right? I think a lot of you guys are either raising money or have raised money, or there's companies out there that have raised tens, if not hundreds of millions of dollars on a great idea and a great service built around generative inference, LLM du jour, or whatever they're doing to speed up AI and ML. I think what's important is it's pretty clear that there's a lot of dry powder out there that's going to be spent. I think that's good for all of us because the interest in AI, not only the things that we can do, but the businesses that can be created from it is real, and we're going to see that money deployed over the next couple of months and years. In my space, we see Cerebras recently did their Series F, Sambanova did Series D. Since then, Cerebras did a big deal, I think, out of the Middle East. With G42. So there's a lot of money out there, and we see a lot of money going into AI in general, but both software and hardware. So a lot of, I think, big industry trends that are impacting what's going on. Now, I said I've been around the industry for a long time. First and foremost, there are a lot of AI hardware companies out there. We are one of many. There's big ones, small ones. I think a good example is South Korea. You go to South Korea, I think there's over 60 South Korean AI hardware inference startups out there. It's pretty incredible. I don't think I've seen this many AI hardware startups, I think in like 10 or 15 years. I'm trying to remember what the last major trend was. But there are a ton of companies out there that are building hardware. And as I said, building hardware takes a lot of capital and a lot of big risk. So I told you I've been in the industry about 15, 16 years. And this huge list of companies reminded me of something. it kind of reminded me of what the GPU landscape was in the 1990s and 2000s. I think a lot of you guys, if you've been around, you know a lot of these companies. I've used a lot of these companies' products, but I also think we know what happened. Over time, all these companies sort of went away, and we were left with really only two. That is NVIDIA and ATI, which we know of as AMD GPU today. So all those hardware companies, for various reasons, consolidated into these two major players. So what happened to these other companies? Some were acquired, fairly simple. Some of them were derailed by execution problems, yield, quality, screwed up design, whatever, you name it. Oops, that didn't work. And some companies missed major strategic inflection points, like 3D and DirectX, et cetera. So lots of reasons, but I think these are the major ones why you saw that consolidation and why you saw all these players really boil down to only two. So then we look at our space, AI hardware. We got lots of people doing lots of different things. So what are the major trends that I think are threatening our industry? And as I said at the start of the title of my presentation, why do I think that we're in the same position, I think, as these GPU companies, where I think there's not going to be many standards, not many people left standing here at the end because of some of these trends that we're seeing. So, trend one. I'm going to go through a couple of why I think the AI hardware companies are struggling, or why we're seeing maybe not the adoption that we wanted. So trend number one, narrowly focused products. I think this is a big one. I told you I saw 50 to 60 South Korean hardware companies. There was a ton of companies on that list. And if you start to talk of each of them, they're saying, hey, well, we're focusing on inference. We're focusing on inference NLP, or hey, we're doing training only, we're doing this, we're doing that. There's nothing wrong with specialization. And I think there's a huge opportunity to build a niche business that you can go drive and make a lot of money. I think the challenge is until recently, it wasn't clear how companies could make money with AI. Now, people are spending money on AI, but if you actually look into it, they're doing a lot of experiments. They're using NVIDIA, they're using their CPU in many cases, and they're trying AI, they're trying to see what they can do, but it's not clear that they found enough use out of AI to drive their top line or bottom line. Now, this story has changed significantly with the advent of generative inference and LLMs and ChatGPT. I think we finally found something that people can latch onto. And it's funny, if you go back to that list, a lot of those companies are repositioning themselves as, we said we were a vision company. No, we meant we were a generative inference company, and our hardware works great on inference, or generative inference, and I'm sure it does. But I think that's part of the business strategy was they focused too small. And the danger with that is NVIDIA doesn't focus small. NVIDIA does inference and training. They do data center, they do edge, they do CNNs, NLPs, recommendation engines, you name it. So if you're going after a competitor like NVIDIA, who has a very, very big moat both on the software and the hardware side, and you're splicing off a bit of that ecosystem and trying to focus on it, I think you're doing yourselves a disservice. So I think one of the things that we've thought about with Tenstorrent is we have to be at least competing on the same level with NVIDIA in terms of what they can do. So it's inference, it's training, it's CNNs, NLP recommendation engines, all in the same silicon, all in the same software stack. And we say from milliwatt to megawatt, but we make sure that we can play in every space because I don't think the market is yet mature enough to handle just splicing off a little bit and going after a certain part of it. So that's number one. Number two, and I think this one is also extremely important. Many of the companies I speak with that are doing AI hardware today, frankly, they're building their hardware around the models of today. That is a huge mistake. And that is a mistake because, as you guys know, we are at the start. AI is at the start. It's at the nascency of where it's going to be. Every time a new model comes out, the model that was popular a month or two ago, completely gone. Every time, look at what happened with transformers, right? Everything's moved to transformers, and we don't know that that's the end. What's going to happen next? So every time a new model comes out, people switch over. It's not like PC, it's not like phone, it's not like there's this slow transition. If the model changes, everything moves. So if you go and build hardware that's designed for the models of today, and it takes you 2 years, 3 years to tape out your product, what happens? I think I have a later slide. I'll give you a really good example of this. But I think that building your hardware to be future-proof and not assuming that the trends that you see today are going to continue is the only way to be successful. I think one of the big trends that we see is around, and this is why Tenstorrent, I think, is what we've made our stake in the ground on. It's the coming together of general compute and acceleration. And we'll talk about why that's important. But we see that major trend with Grace Hopper with NVIDIA. We see MI300. I think it's pretty clear that having this combination of compute and acceleration is important, and being able to future-proof your hardware to ensure that you can run the models of tomorrow is also extremely important. Unfortunately, what I've seen with most of the hardware companies, just like they did with their business model, their hardware is designed around architecture that might not necessarily be around or be relevant in a year or two. You know what, I think I'll tell that story now. I'll give you an example of one of our customers. So one of our customers came to us, it's in the automotive industry. We haven't yet announced it, but they're like, okay, we want to go and build an inference engine that, probably for driving the cameras or something. And they're like, Int8. Int8's the most important thing to us. For those, I don't know how familiar you guys are, but it's a data type that is kind of popular with the vision models of today. So our argument was, okay, we can do that, but if you look at the trends in the industry, it's all going low precision floating point. If you look at everything, we think that you're going to have some flexibility. They're like, no, we know what we're doing. We know exactly what we want. Build us this. So we said, okay, no problem. 6 months later, lo and behold, they came back to us and said, hey, we just got a new model. We need low precision floating point. We need to go back and redo our data type. So in that case, we were okay. Our hardware, we have everything already in there. It's easier to take out than it is to add in. But I think it goes to show that models are changing so quickly. To build your hardware around what models look like today and not what they're going to look like in 2 or 3 years, I think is a dangerous mistake. Customized software solutions. This is another thing where we see a huge challenge to most of the AI hardware startups. And what it boils down to is every time a new model comes out, it takes 60 engineers and 6 months to get the model up and running and optimized. Now, NVIDIA in some sense does not have this problem. In many cases, the models are designed on NVIDIA, so they work out of the box. But even NVIDIA has got an army of engineers out there making sure that they're optimizing the models, getting the most out of the performance. This is great if you're NVIDIA and you've got thousands of people and lots of money and everyone's using your hardware. If you're an AI hardware startup, it is absolutely 100% not scalable. We need to have both the system and the hardware, the software and the hardware working together that runs things as smoothly as possible with the least amount of interference or least amount of resources required to go get it running. So the whole hand coding and optimizing is not scalable. I think I say here, industry needs models to run automatically and performantly. So this is one approach that we took, but I think it's something, I think it speaks to a broader trend. So we have 2 software stacks that go into our hardware system. One of them we call Buddha. I think we're about to announce a rebranding of that. I thought Buddha was pretty clever. Some other companies didn't think it was as clever as we did, so we're going to go change it. But Buddha is a top-down general compiler with one goal. It's to take AI models and run them out of the box as performantly as possible without the need to hand code to get them to work. So general compilers we know are very hard to do, but we believe this is extremely important in getting adoption around our hardware. So I want to kind of take a look at why that is. So if you are a company that's you've purchased a whole bunch of NVIDIA GPUs and an AI hardware company comes to you and says, hey, we want you to switch over to our hardware. It's almost impossible. Why is it impossible? You've already got an investment in hardware that works really, really well, and you've got your software stack and your tool chain is all built around that. So what reason would you have to change? I think there's 2 reasons. Let's say that you offer 10x performance. I think 10x is the magic number where a company could say, you know what, screw it. I'll buy your hardware, I'll redo my software stack because I'm going to get 10x performance. Unfortunately, I don't think that's realistic. NVIDIA is throwing everything at this problem. They're using expensive HBM, they're using the latest semiconductor foundry node. They're really putting everything in these products. They're fantastic products, that's why they cost so much. So how can you be 10x better when they're putting everything in the kitchen sink in there? You can't. I think it's a physics problem. Okay, then let's look at the other side. If you can't be 10x better, then how do you get companies to adopt your hardware? I think you can't mess with their tool chain, you can't mess with their workflow. You have to seamlessly integrate in such a manner that it's so easy for you to take the models and go run it without sort of impacting what you're doing today. So that's the approach we're taking with Buddha. We're saying, okay, take your models as is, you don't have to make any changes, we're going to run it out of the box, we're going to run it well, go on a Hugging Face, download any model, it'll work out of the box. Sure, we will give you the opportunity to optimize it, but we want it to work as best as possible out of the box without too much interference from us. And I think if you get into that space, if you get into that seamless integration, then you can start to play with the performance and price knob. You can say, hey, I'm 2x better, 3x better, and I'm half the cost. But you can only do that if you don't have to interfere too much with their software stack and the tool chain. On the other hand, we've got our metal stack. I think this is crucial for, and probably what's missed by most of the other software companies that are AI hardware companies out there, is that it's proven to us that developers want to have full control over the hardware. So while we have Buddha to run the models and allows the folks in this room to go iterate, play around with different models, mix and match, tweak their models to get the most out of it, with Metal, you can program your own kernels, and that means you can, you can do the hand coding optimizing of ML models, or if you believe that our architecture could benefit a non-machine learning application, I don't know what it is, HPC or some sort of finance application, whatever application you want, we're giving you open access to our hardware. It's kind of like CUDA, but nothing's encrypted, a complete map of our hardware, and the ability to program in simple C++, your own kernels and codes to run any application you want on the hardware. So I think having these two modes of operation for your two entry points into the software stack is important for developers. Last one. Why do I think AI hardware companies are in the sort of difficult position that they're in? They're taking on a lot of risk. So I told you, I think the dirty secret about AI up until very recently was it's unclear for companies how they're going to make money with AI. Now that's, fortunately for all of us, that's changing. But up until last year, it's very hard for a company to make an investment of tens of millions of dollars on a proprietary hardware solution that only runs machine learning when they already have a whole bunch of GPUs that can do a whole bunch more. Making hardware, you got high burn rates. Your CapEx is extremely expensive. You've got tape outs. You've got a lot of people designing the hardware. It's a very, very expensive business to run. And frankly, as I said, NVIDIA has an incredible moat with what they've done with their hardware, what they've done with CUDA. And unless you can plug into that seamlessly, it's very hard to get people to shift off unless you've got a value prop that is either 10x better or super easy to integrate. I think what we found at Tenstorrent is we believe the future of compute or the future of AI is this coming together of general compute and acceleration. So, Jim Keller, my CEO, and his team, they've built out a very, I'd say probably one of the best CPU teams in the world, and they're building out this RISC-V IP that will be a companion to our AI. We've been fortunate that we've had a huge amount of inbound interest on our IP. And I think the next opportunity for AI hardware companies is there's demand out there for IP that they can use, and more importantly, IP that is silicon ready, silicon proven, has a full software stack, and is able to plug into their, the workloads and the designs that they want to make. So I think in terms of what I see is, if we were just in the same boat and we had to go sell a whole bunch of hardware against NVIDIA, I still think the market's maturing so that we can have some viable competitors to NVIDIA. And I think we're fortunate that we're able to monetize some of our technology a little earlier than that. So I told you, I know we got no more time. Am I good on time? I don't even know. I want to talk a little bit about our roadmap. If you guys have been looking online, or if you know anything about Tenstorrent, I think you've seen this. But we've now on our third generation, I guess we're taping out our third generation of product here soon. So Blackhole's taping out. It should be available next year. But we've taken this approach in that, like I said, all of our generations are all of them are available in PCI cards. They go into servers. And the way that we've taken our approach to AI is quite different than a GPU. We use something called a data flow architecture. The compiler actually lowers the AI model to a graph, maps it on the hardware, pushes it through. And we've made some pretty interesting, I think, bets on technology. We said that the future of compute is the coming together of this general compute and acceleration. Very early on from our initial Grayskull design, we said, hey, we think low precision floating point is going to be a thing. So FP32, FP16, FP8, BFP8, BFP4, we've had that in our earliest version, and that continues through. We then said, okay, we think sparsity is going to be a thing. I think that proved itself out. We then said this coming together of compute, and you see that in our Blackhole generation, we're bringing the RISC-V cores closer to our architecture so that you don't have to go off system or outside of the silicon. You can do all your compute inside, both acceleration and compute inside the chip. And then I think more importantly, as we move to our next generation, we believe that chiplets and sort of the coming together and mixing and matching of the right balance of compute for your workloads is where the future is going. So having this flexibility to inference and training, to go on the edge, to go in the data center, to mix and match the right I/O subsystems, memory subsystems, and balance the right amount of compute and acceleration that you need, I think is going to keep us nimble enough to hopefully weather the storm that is coming. I know we get often asked about our RISC-V CPU and what we're doing there. As I said, it's the important balance of that AI and compute is important. We're building what we believe to be the world's highest performing RISC-V CPU. We've had a tremendous amount of interest in companies that want to license that IP as a standalone, but Tenstorrent as a company, we will be releasing our hardware with this combination of AI and RISC-V together. And I think the reason's apparent. If you believe, and I think a lot of people in the room do, that the future for enterprise are these LLMs, And the LLMs are getting smaller and smaller. And companies and enterprises want to take their data and put them into these LLMs. And they want to have up-to-date access to their own personal data, ideally not on the cloud. You need a high-performance compute that's able to feed that data into the LLM, stage it, and then take the data back and transform it. So again, this combination of compute and acceleration is important. And I think what's interesting is, for those of you that follow the hardware industry, I think you've seen that Intel has proven it's very hard for a CPU company to make a GPU. And I think you're about to see that it's very hard for a GPU company to make a CPU, especially a high-performance CPU. It's not hard. But I think at Tenstorrent, I think we've managed to hit something that is balanced on both sides. Last slide, I promise. Our business is, like I said, we've made some announcements this year. We've got some more announcements coming out at the end of the year. But from LG to automaker, I think we have LG, Hyundai, Samsung. I think we've seen a number of different verticals and a number of different industries that are saying, hey, we want to own our own compute, number one. We believe your approach to open standards and open source with RISC-V and opening up your AI hardware is the right way. We want to buy your silicon and we want to buy your IP because we want to do our own thing. And we've seen that approach has been, I think, quite successful in attracting companies that want to own their own compute. And when you own your own compute, that means owning both your general compute and your acceleration. And the trick is how you integrate those together. So more news coming. If you're interested, you can visit the website. But I think we'll have some major announcements coming at the end of the year. And I remember now that I was asked to say, for those of you that are interested in using our hardware, if you want to try a hardware that doesn't happen to be good at AI, but hardware that's designed with AI models in mind, we'll be releasing a dev kit, I think, before the end of the year. And this dev kit, we're hoping to have people try it out, give us feedback, let us know what we've done right, let us know what we've done wrong. And our goal is to make sure that we continue with each generation to drive a solution that will be a viable alternative to NVIDIA in the short term, and hopefully provide an alternative to NVIDIA in a bigger way in the long term. So thank you very much. Appreciate everyone's time today. Thank you.
We do have time for some questions.
Thank you.
How important or unimportant has it been maybe to you guys as company trying to compete with NVIDIA that, say I'm a teenager, I have a computer at home, I like the game, I probably have an NVIDIA GPU, I find out about machine learning and I can just get up and running on the hardware that's already there. So then I get used to that stack, I get used to that hardware, and then I start my career in AI, and that's pretty much what I'm used to, and that's what I'm probably going to use. How is that challenging to you guys, or do you guys have any solutions? I don't know, solutions for that, or have any thoughts about that?
No, I think you're right. I think that's the biggest problem, right? And actually, I would say it's not even the GPU. If you look at most AI development, it's done on CPU today. So people ask us, well, who's our biggest competitor? I mean, yeah, it's NVIDIA, kind of, if we're looking at the really big deals and the big picture where we want to make a lot of money. But if we look at the average developer that's just learning, teaching themselves AI, it's the CPU by far. So I think, as I said, that's why you see companies like Modular coming out, trying to sort of create an even platform to everyone to be able to kind of use any hardware they want. I think our goal is really simple. We make it so easy that when you do get our hardware, you don't have to change what you've learned. You can plug it in, you can start to play with the models, and hopefully it works very smoothly. But more importantly, we're looking for people that are passionate about AI and ML and believe that it's the future. And if you listen to Jim talk, our CEO talk, he said that he believes the next generation of computers are going to be designed by AI, and we want to get there first. But our goal with that is by releasing the dev kit and providing an alternative architecture, because the way that we handle machine learning is extremely different than a GPU, right? We take machine learning models, we lower them to graphs, we take that graph and we lay them across the hardware. It's like a graph computer. We're looking for people that believe that AI and ML is the future and are looking for an architecture or hardware that could potentially enable you to do things that a GPU can't. So we're hoping to find the people that want to take it an even step further and start to play on architecture that was designed for machine learning in mind, and what we would say is kind of like a real modern architecture approach to machine learning, and find the people that want to play with that. But yeah, it's a hard problem. Oh, we got more questions. Yeah.
Are you using? Are you designing actually like sort of separate accelerators, or are you like using the instruction set, the extensions of the instruction set of RISC-V to do like scalable vector instructions.
No. There are some people that are doing that. I think who was Esperanto was doing that. We're not. We have this is an entirely, it's an accelerator design. We could go deep into it, but it's a standalone accelerator. If you get really, really, really technical, inside of those AI cores is super interesting. We actually have a RISC-V. We have 5 little RISC-V cores inside each of those AI, but that's the way that we're handling compute, right? But basically, it's a standalone accelerator, and what you see in Blackhole is then we're putting more of a general CPU. We're lining up a general CPU beside it, so that as we move the graph through there, if there's some operations that need to be close to memory, we'll place the operations close to memory. If there are some operations that can't be done in the accelerator or perform better on a CPU, we'll put them on the CPU. And then we can do things like we can take the results of an operation done in the accelerator to the CPU, and before cleaning the memory, we can actually take it to another part of the chip and do some calculations. So there's a lot of interesting things we can do as the data flows through the architecture. But long story short, it's not just RISC-V running, with vector and running AI. This is a standalone accelerator that we are then pairing with standalone RISC-V compute, and then as we get to our 24 generation, we're really integrating them, I think, in a way that's going to be even much more tightly integrated than what you're seeing coming from MI300 or Grace Hopper. You can stop me if I say stuff I'm not supposed to say, by the way. Like I have a feeling I'm just saying everything. I'm bad with that. All right.
Thoughts on companies trying to design their own ASICs?
Sorry, I couldn't hear the last part.
Thoughts on companies that are trying to design their own ASICs?
Own ASICs. Well, that's what we do, right? So we design our own ASICs. I'm sorry, your mic cut out.
To use them directly, within the company.
Sorry, your mic.
To use them directly within the company,
So first of all, we're designing our own ASICs. There's a lot of companies out there designing ASICs. Our number one goal, and you see why we're moving to chiplets, is we believe that more companies should make their own hardware, and we believe that companies that do make their own silicon and own their own compute, Amazon, Tesla, have a significant advantage over other companies. Why give your margin to NVIDIA or AMD or Intel when you can go right to the foundry and then really drive what you want? So they are competitors in some sense, but it's what we're doing, and we're enabling that strategy. And frankly, to compete with ARM and to compete with NVIDIA, because we're competing with both. On RISC-V, we're competing with ARM, and NVIDIA, we're competing with our accelerator. We need a healthy ecosystem. So we're actually about supporting the ecosystem, bringing up lots of competition, so that we can have a healthy alternative, a healthy choice to what currently is monopolizing the market. I hope that answered your question. Any other questions? Apparently I'm in a talkative mood. If you want to know something secret, now's the time to ask. All right, guys, appreciate it. Thanks for the time today. Thank you.
We are taking a little break for lunch now. Thank you.